a warm welcome. I'm going to start relatively slowly, just give people a chance to come and sit down. Yeah, this talk, it's actually quite a big talk. We've got 83 slides to get through. And it's all about refactoring, specifically about refactoring CSS. But what we will find is that some of the principles we look at could be applied to JavaScript, Java, PHP, whatever. So it's going to be quite a philosophical talk. We will start off, or it's going to start off quite philosophically. We're going to look at things like deciding what we should refactor and when, proving a business case for refactoring. Has anybody ever struggled to get their client or manager to allow them to refactor something? Yeah, right? Because who's going to pay for refactoring? It doesn't look like anything. So what we'll look at is ways of fighting for that kind of that time or that budget to tidy things up. Then after that kind of first half of the talk, we will start looking at specific approaches, specific tactics to use when we start refactoring CSS. I'm not going to make refactoring enjoyable, because refactoring is not enjoyable, never enjoyable. But hopefully we will at least make it a little bit easier, a little more predictable, a little more consistent. So if we are looking to get the time and the budget to start refactoring our code, how can we do it in a fairly consistent, replicable, and sort of safe manner without regretting everything else? So, yeah, I'm Harry. That was a nice, quick intro I got. So don't need to say much more. I'm a consultant front-end architect from the north of England, which goes some way to explaining the weird accent. I don't have a normal British accent. But being a consultant means that I deal with a lot of clients at very short periods of time. So I might work with, I don't know, 70 clients in a year. Not as many as that, 50 clients in a year, only for a few days or weeks at a time. So it's really quick, short engagements, which means I get to see a lot of bad code. Right? There's a lot of people with a lot of legacy, a lot of tech debt, a lot of things that have gone wrong. And I tend to do this with big companies. Just by the way things have happened in my career, I tend to work with quite large businesses. And with large businesses, you get bigger teams, you get bigger code bases, you get older code bases. You get a lot more tech debt in a larger code base because statistically there's more chance of having older code. And because of this, I get to do I have to do a lot of refactoring. I have to look at a lot of old code and help clients identify problem areas and help them fix it. And the problem with this is, I actually really hate refactoring. A huge part of my job is refactoring CSS, and refactoring CSS absolutely, it just sucks. Has anybody refactored any CSS before? Put your hands up if you've refactored some CSS. Okay, keep your hands up if you enjoyed that process. There's a few crazy people before me. I don't trust any of you anymore. Now here's the thing, right? Refactoring, it's a fairly shitty job, right? Actually doing the refactoring kind of sucks. When you sit back after a refactoring project, and you look at the progress you've made, you look at the improvements you've made, that feels really good. Now, I enjoy that bit, sitting back and thinking, you know what, it's going to be so much easier to work with this code base for the next 12 months because I spent a bit of time refactoring. But when I'm actually trying to refactor importance, I hate that bit. That's the bit no one wants to do. So in this talk, we'll try and make it a little easier. Again, not enjoyable, it's impossible. A little easier to start refactoring our code. So what do we talk about when we talk about refactoring? Well, there's a really nice definition by a guy called Martin Fowler. Has anybody heard of Martin Fowler? A few of us. He is the chief scientist at ThoughtWorks, which is a pretty badass job title. But this guy's a genius. I read everything he writes. I understand about 3% of it, but I still read all of it anyway. So look this guy if you've not heard of him before. He describes refactoring as the process of changing a software system in such a way that it does not alter the external behavior of the code, yet it does improve its internal structure. And the first thing that I think when I read this is that, well, that means that refactoring isn't really for our users. And by definition, it doesn't change the external behavior, so the user would never notice it happened. So it means it's a business decision. It only improves things for developers, it improves things for internal stakeholders. So this isn't really for our users. However, this isn't the main reason why we struggle to get funding for refactoring. This is the main reason why managers and clients don't like spending money on refactoring because it isn't for users. However, I make a bit of an argument, which is that it's not directly for our users. It's not going to all of a sudden create 1 million more signups in a month. But what it will do is it will indirectly trickle through to our customers and our users, because if we've got a nice, clean, refactored code base, that means that there are probably going to be fewer bugs and fewer regressions. Customers will be using nice, clean code that's been very well looked after. It means they're not going to notice inefficiencies or performance bottlenecks. They're not going to notice the sort of knock-on effect of bugs and regressions. And also, I would argue that if we are working in a nice, clean, refactored code base, we can add features much more quickly. That means we can get things in front of customers much more quickly. That means if we're working in a very nice, refactored, clean code base, we can actually satisfy customers quicker, right? We can get things to them quicker than if we're dealing with a horrible code base where one feature takes twice as long to build. This is the first step for me when I try and encourage my clients to start refactoring, is to explain to them that, look, this feature that you built took 6 months, and that's mainly because we had to understand all the legacy code that propped it up. If we didn't have all that legacy, if we had refactored, we may have shipped this feature in 2.5 to 4 months. That means we could have made money from these customers much more quickly. So again, on the definition, in my opinion, or certainly kind of for this talk, there are 3 main kinds of refactoring. There's the kind of as-you-go refactoring, and this is the stuff we should be doing all the time. This is when you are just working in a code base and you see something a bit messy and you tidy it up. Or it's when you need to build a new feature and you go to CodePen or JSBin or JSFiddle and you prototype it there and you hard code everything and you work out that, hey look, this kind of works, so I'll copy and paste it into the project. But you don't just copy and paste it in, or hopefully you don't just copy and paste it in. You would start refactoring it to use variables from a SaaS project or use mixins from a SaaS project. You start documenting and commenting it. So this is the stuff we should be doing all the time. If we don't keep an eye on this, if we don't do this all the time, we step into the next kind of refactoring, which is a little more expensive, and this is technical debt. Technical debt is usually a case of we did what we thought we could do, or we did what we were able to do given the money or the time or the resources we had available. But now, looking back on things 6 weeks later, we realise that we could have done it differently or done it better. Has everybody heard the phrase technical debt? Yeah, most of us. Yeah, a lot of laughs like, dude, my life is technical debt. We will look at technical debt in a little more detail soon, because it's one of these things that a lot of my clients and all of the developers I work with, they actually subtly misunderstand what technical debt actually is, so we need to kind of redefine that a bit. And finally, we get into the rewrite or overhaul, and this is where the code base has become so hard to work with, it's become so difficult to adapt or difficult to extend, that there is a business decision that gets made that, look, we should tear everything down and start again. We could rebuild everything from the ground up. Has anybody been part of a rewrite or overhaul project? This is where you say, oh, we'll do it right this time. Yeah, sure, we said that last time. Rewrites and overhauls are really expensive. They're very risky. They're a very high risk thing. So what happens is that companies try and avoid rewrites. So what it means is you end up with a technical debt stage for like 10 years, and it just keeps getting worse. And then when they finally say, well, we'll tear it down and start again, it becomes a huge project that's very stressful. And part of the reason that is the case is because as we progress through a project, the type of refactoring that we encounter begins to change, and the cost and the size of that refactoring task changes as well. The as-you-go refactoring happens right from day one, and it costs minutes to hours, right? It's a very cheap kind of refactoring that we can do fairly effectively and fairly quickly. Now, if we don't capture this, like I said, we step into the technical debt arena, and the technical debt is going to be costing days to weeks, right? It may take a few weeks to refactor something that is classed as technical debt, so it becomes more expensive. If we could just capture everything on the left-hand side, we may have saved some money, but we didn't have time, or we didn't think we had time, or we didn't understand the problem properly, so we end up having to spend more money on our technical debt task. And then if we don't capture the technical debt task, we end up in this huge blob on the right, which is, it's going to be weeks to months, right? It may take 6 months to a couple of years to actually fully rebuild a platform to be back to square one. Now, the reason rewrites and overhauls are so expensive, and people don't like doing them, is because, well, just think of the cost involved in rewriting an application. Let's imagine it's going to take you 6 months to rebuild your platform, and that's a very nice sort of low estimate, but that means that the business has to find 6 months to pay developers to work on something, right? That's 6 months of salaries and rent and everything. So that's the first cost, is actually employing people to do it. But the second cost is, that is 6 months that those developers can't spend building new features. We're basically incurring a huge opportunity cost, where we are spending 6 months and 6 months worth of money just getting back to effectively the same product that we had before, just with nicer code. And this is why businesses don't like paying for refactoring, because it's very hard to see the benefits in the immediate term. So just to look at technical debt a little more then. So most of us have heard of technical debt. One of the things I find really interesting about technical debt is that a lot of people think that technical debt and bad code are the exact same thing. Technical debt is actually a business decision. Technical debt is developers and managers making a decision to hack something now to get it released early, but understanding that that was a hack and understanding that you need to repay those debts. A lot of clients say to me, oh Harry, we've got a lot of technical debt, and I'll take a look, and it'll be like, well, you kind of actually just got a lot of bad code. So you can't really call all of this technical debt. This is just lazy developers or people not taking pride in their work. There is absolutely a difference between bad code and technical debt, and it's really important to spot which one is which, because bad code is a lot worse than technical debt. Technical debt, the implication is that you understood what you were doing, whereas bad code is you didn't really care what you were doing, right? So there's a really, really great article called Technical Debt 101. And in this article, these slides are already online, so don't worry about trying to take notes of URLs. Technical debt is summed up really nicely. It's very similar to a real-world debt, right? So a debt means that you acquired something right now in exchange for a long-term financial burden. This burden is just not about repaying what you've got, there's also interest involved. This means that even if you pay your debt timely, you'll pay more than you took, and if you don't, your debt will keep increasing. If you ignore your debts for long enough, it will become unpayable, and you will become bankrupt, you'll go bankrupt. This is a complete, perfect one-to-one analogy with real-world debt. Debt is something you're aware of. If you get a mortgage or you take a business loan, you know for a fact that money isn't really yours. You know that, right? It's a debt. You also know that you have to pay things back. But because code, we can't feel it, we can't touch it, and you can't really go to prison for it, we don't treat it as seriously. It's still the exact same. It's still a debt where we've got something right now in exchange for a long tail of kind of financial repayments. But there's very little incentive, it seems, to pay these debts back on real development projects. One thing we have to be comfortable with is that technical debt is going to happen. On any project of a reasonable size, there will be some technical debt. And we shouldn't feel bad about that. So technical debt, I'm really keen to kind of enforce this. Technical debt isn't necessarily a bad thing. Technical debt could allow you to get to market 6 months before your competitor, which means you've got 6 months to make way more money than they do. The important thing is you spend the next 6 months tidying things up. That never seems to happen. So technical debt is fine. It's a strategic business decision, right? It's not really about developers, it's more about business decisions. But it's vital to get to pay these back. And this is why it's really important to start making the business case as developers, explaining to managers and clients, hey, look, we really need to start refactoring this because we're not really on a sustainable foundation. So yeah, schedule bug fixing into sprints. If you do like a sprint-based development workflow, make sure you've got at least a day of sprint just to tidy up technical debt. A really good strategic approach to refactoring is just to refactor the things that touch the bit of work you're doing. So let's say you need to add a certain feature into a certain part of the code base. Refactor everything that interfaces with that new feature as you're doing it. So it's this as you go refactoring, but it's a little bit larger. What this means is that you can incorporate that estimate, that cost, into the cost of the feature. If you think, well, I can hack the feature in 3 days, but I also want to tidy up the API that feature talks to. So I'm going to estimate 4.5 days, and I'll incorporate that refactoring into the feature cost. That's really where sliding technical debt in without you need to ask your manager, right? It's easier to ask for forgiveness than permission, just get it. But yeah, on the other hand, if we've got large refactoring tasks, we do need to start proving the business case. Which brings us on to, when should we refactor and what should we be refactoring? Now, my politician's answer to this, my very lazy answer is like, we should always be refactoring. There's never a time that we shouldn't be tidying things up. But that's not really very meaningful, right? That doesn't really tell us what to do. So to make it really, really quite digestible, if the projected cost of maintaining a feature is actually higher than the cost of rewriting it, then we should probably rewrite it. If we think that this kind of poorly implemented feature might cost us 2 weeks to maintain over the next 12 months, but we think we could rewrite it in 10 days, then that 10 days is obviously the cheaper thing to do. Now, the problem is you've got to convince your manager that, hey, look, if we spend 10 days on this, we'll have an extra 4 days to just do something else. That's the immediate start improving the business case. You need to have these numbers. Which means we need to be good at estimating, and developers are really bad at estimating things, myself included, but we'll look at a task for that in a second. And another good time to start refactoring is if you've got noticeable problems with a feature. If a feature or a part of the code base is genuinely, measurably slowing you down, that's a time to refactor it. Many years ago, I worked for a company where we had lots of different test servers. So we'd have like test 1, 2, 3, 4, 5, 6, and so on. And each feature team had a series of test servers that they would run their end-to-end tests on, their integration, all this stuff would happen on these test environments. These test environments were just awful. They kept going offline, they kept being unavailable. So nearly every standard, we would ask the test engineers, oh, has feature X been tested? And they'd say, oh, no, test 6 is down, so we can't do anything on it. But this happened every single standard, every single day. And the business didn't really notice the cost of this at the time, because it was just, oh, test 6 is down again, and people just carried on with their jobs. We had a really good Scrum Master, and she was getting really, really annoyed at the sort of how unreliable the infrastructure was. So what she started doing is every standard, she said, well, how long should these tests have taken? I don't know, an hour and 20 minutes. Okay, but how long is test 16 down? 4 hours. And she kept a Google document, a Google sheet of how much it should have cost and how much it did cost. And after the end of one phase of work, I think it was like 6 weeks of work, she went to the high-level management and she said, look, we lost about £10,000 this phase because test 6 and all these test environments kept going offline. As soon as she could go with those numbers, the checkbook came out. Checkbook, it wasn't that long ago, the credit card came out. And we got money to solve this problem, right? So having hard data is really, really valuable. If something's slowing you down, measure how much it's slowing you down by, and then work out how much that's costing. Your yearly salary, let's say a feature costs you 1 extra day every month. You can work out what a day of your salary is, which is divided by your salary, you know what it is, and tell your manager, hey look, all of these days I was granted from doing this work. That actually cost the company this many thousand leather, right? You can work that out. And then yeah, also, even if you're not being slowed down, there is an interesting case where the new version of something might make you much faster. You might look at a code base and think, hey, there's nothing actually wrong with it, and adding a feature isn't difficult, but if we just swapped out this technology for this one, adding features could be completely automated. So refactoring isn't always because of something being bad. There can be a case where something is just measurably better. Okay, really quick example. I do this exercise a lot with front-end developers. I'm a CSS person, so I deal a lot with front-end devs. And this exercise is helping developers get used to the idea of estimating and proving a case with data. I've got a little table here, and it's a native project, this doesn't exist. But because we're talking about CSS, let's imagine that this table represents the cost of adding a theme to a website. The 2 columns, one is the existing code base, which is a mess. And the other column is the refactored code base. This is the code base, if we were to tidy it up, given some time to refactor it, those are the 2 columns, 2 different versions of the code base. And each row is the cost of implementing a feature, in this case a theme. So let's imagine we've got a website and the initial spec didn't mention anything about theming. The initial spec didn't mention themes at all. So we built it to just look the same way every time. Then a customer comes along and says, hey look, we want to use your software, but we need it to look like our brand, so we need a theme. We've got 2 options. We can hack a theme in there, just spend 2 days just like stuffing a theme into the CSS and hoping it works. And that's fine, that could well work, and that customer will sign on the dotted line and you've made a bunch of money. But the next thing, or the next time the customer says, hey look, my friend at so-and-so company uses your software, we want to use it as well, can we have it themed like our branding? We're going to spend 2 more days hacking a theme on top of a hack, and then so on, until it now starts to cost 2.5 days, because this is the interest, it's getting more and more expensive. So what we could do, the other option we have, is to say to our product owner, hey look, we can put a theme into the code base, very hacky, but it's not going to be very sustainable. What I would like to do is take 7 days of my time to refactor the CSS so that theming is a first-class citizen. So that we just need to drop a JSON file on the server, or we need to just drop a new SAS config file into the project with a few brand guideline sort of variables, and that means that after the first 7 days, adding a theme can take a quarter of a day, which needs to add a new JSON file somewhere and the site will build itself. And what this is about projections. We've got to make sure that we can fairly reliably estimate projected costs. Now, if you look at the top row, the 2 and the 7, and you take that to your project manager, we all know which one they're going to pick, right? 2, please, no 7. Don't spend 7 days, spend 2. Then you have to actually say to them, yeah, but if we get more requests for more themes, we're ultimately going to spend 9 days on this. If you allow me to refactor it now, the overall cost could be as low as 7 3/4 days. Now, this is really important to be aware of it. You have to be good at the projections. You have to make sure you're comfortable doing this. We also have to be really aware of the risk of premature optimization. This assumes that 4 people will ask for a theme. If only 1 customer ever asks for a theme and you spend 7 days implementing it, then you've actually made a loss. So you have to be very aware of potential outcomes. But I think this is a very important exercise for developers. It allows you to start understanding the business costs and the associated business costs of the work we do. This is a real simple exercise that I go through in kind of workshops with clients, and it really helps developers get used to this idea of cost projections. What the column on the right represents is technical investment. We've got technical debt. It sounds reasonably, the opposite of technical debt would be technical investment. Okay, we've got something else. We've got the opposite of when we should refactor. This next slide, please don't tweet it because out of context it looks like terrible advice. When do we not refactor things, right? There is absolutely a business case for not refactoring something. If something isn't actually slowing us down, if a feature isn't actually problematic, there's no point spending any money rebuilding it. A lot of developers I work with refactor out of a sense of pride. Oh, we could rewrite this using this new library. Well, that's just because you want to. That's not actually an important business thing. The second bullet point is really bad advice out of context, so I see people taking pictures of this, and I'm already nervous. If it's something that can be ignored or avoided, how bad does that sound? So I'll pretend it's not there. This actually exists. If you look at the banking industry, all banking websites pretty much are built on COBOL or even Fortran. And at some point, the last COBOL developer in the world will die. And what do we do at that point? So what we do is it's a design pattern called facade. And we've got Java engineers, very enterprising people who will write facades, APIs onto Fortran and COBOL backends, because we can't really afford to refactor the banking system. I would like to meet the product owner who would sign that off. Yes, just rebuild banking. We can't do that, so we build a facade. We ignore how the COBOL and Fortran works, but we understand the abstraction on top of it. This is a genuine design pattern. If we can ignore part of the code base by building APIs onto it, that is another good example of not refactoring yet. And sometimes rewriting is the better solution. Sometimes you just inherit a code base so bad that you just got to rewrite it. You just have to tear it down and start again. Some real examples of this from work that I've done. You're saying, oh, we want to rewrite our CSS onto BEM, right? The BEM naming convention. Now, anybody knows me knows that I absolutely love BEM. I think BEM is a fantastic way of naming your classes. But I don't really think that spending 2 weeks refactoring your class name is going to pay itself back very quickly. Just sort of renaming your classes is going to be a very big job. It's going to take a long time. It's probably not actually worth it from a business point of view. Unless you can prove that it will pay itself back. If you think that if we spend 2 weeks rewriting our class names, then we'll get 3 weeks worth of increased productivity, then you can prove, if you can prove it's the right thing to do, then it probably is. Worked with a client who told me on our day one of working together, we sat down and we looked at things we could do during the week. And so we think the code for the nav is pretty ugly, we'd like to refactor the nav. So I looked at it and they were right, it was really bad. But I asked them a few questions, because I was there as a consultant, right? And consultants aren't the cheapest people to have in the building. I was like, well, is it worth paying me money to rebuild a nav? Like, it seems like a thing that needs someone external to do that. So I asked them a few questions. Is the nav causing you any actual problems? Is there anything wrong with the nav right now? Turns out it was accessible, worked in every browser it needed to, it was completely fine. So it wasn't actually problematic. So my next question was, how often do developers have to work with this code? How often are developers annoyed or slowed down by the code in this nav? And the answer was, well, actually, the CMS, like a user just adds a new page and it just appears in the end of the nav, so developers never need to touch it. So my next question was, well, can't we just leave it alone? If it's not slowing you down and there are no bugs there, the problem really is that you just don't like ugly code. And that's good, that's good. But is not liking ugly code worth hundreds of pounds to you? And I don't think it is. We can ignore this feature and refactor it later. So there are absolutely good times not to refactor, and it's important to be aware of those as well. Right, okay, let's get on to some practical tips. So I came up with a concept about this time last year. I was working with a fairly large client in the UK, and we wanted to start refactoring some stuff. One of our tasks was to work out what we should refactor. And people kept picking these really ambitious things like, I want to rewrite it, or I want to post CSS, and I want to use this naming convention. So I came up with the concept of a refactoring tunnel. And the metaphor works like this. A refactoring tunnel represents a piece of work, a piece of refactoring work. The length of the tunnel corresponds to how long that task will take you. A more engineering way of looking at it would be the task has a large surface area. If the task touches a lot of the project, touches a lot of endpoints or whatever, that would be a long refactoring tunnel. And the metaphor works like this. You pick a refactoring task, and day one you start work, and you step into the tunnel. Day one, you're in the tunnel, and you can see the entrance behind you. You just walked in. You can't see the exit. You're not sure how far away it is. It's probably around the corner somewhere, but you can't see the lights at the exit. Day two, you step in a little bit further. You can still see the entrance behind you. You still feel quite safe. You still can't quite see the exit. You carry on working blindly, just hoping you'll find the exit at some point. And 5 days later, you're in the middle of the tunnel, or you think you're in the middle. You can't see the entrance anymore, and you still can't see the exit. And you don't know if the exit is just around the corner, or if the exit is like 25 days away. You just don't know where you are. And the site's completely broken. The nav is laying by your feet somewhere. You try to refactor the contact form, and now the modules are broken, right? Have you been in this situation before? You're trying to read it, it's like, oh shit, everything's ruined. And on day 5, you just do this. Who's done this before? I certainly have, right? You spent 5 days trying to refactor something, you had all the best intentions, and you leave everything so broken and so confusing, you just have to throw it all away and start again. I've done this too many times. I've done this more times than I would care to admit, and it's taught me a valuable thing. Avoid long refactoring tunnels. Do not refactor anything that has a large surface area. Don't refactor anything that is big. Moving all of your SAT onto post CSS, that's quite a big task. Maybe just refactor a part of your SAT onto post CSS and run both at the same time. That's not perfect, but it's better than having to throw everything away. Moving from one naming convention to the next in one kind of task is a huge, huge thing to ask, and a lot of things are likely to go wrong in the meantime. So avoid anything that runs through your entire project. Takes too long and leaves things very messy. We get really specific problems. Like imagine if you were to rename all of your classes onto a different naming convention, you're going to get a lot of merge conflicts there. Actually, just literal developer problems of trying to merge a delta that big would be horrible. Instead, find small tunnels, refactoring tasks that only capture a very small amount of work, and work on those really rapidly. So pick a small thing to do like refactoring the nav, get the work completed, and this next bit is the bit that managers love. If you tell your manager, I'm going to refactor all of our SATs and it's going to take 6 weeks, you're not going to get permission to do that. However, if you tell them, hey, I just want to refactor the nav, and in 3 days' time, I'll be available to work on product work again, they'll give you that 3 days because they know they're not losing you for 6 weeks. So after you've refactored the nav, you can say to your manager, hey, the nav's done, I could move on to refactoring the buttons next, but is there anything you need me to do first? Managers love this because it means you're available again for product work very, very quickly. And rinse and repeat, just keep doing this and the site refactors itself. Pick off small bits, and over time, everything gets kind of tidied up. When we identify these short refactoring tunnels, it's important to do them in isolation. This is particularly important with CSS. CSS operates in global scope, so it means that everything borrows something from somewhere else. So what happens is, if you rebuild the nav directly into the same problem code base, that nav will be utilizing CSS from elsewhere that in turn might also get refactored. That makes sense? So you might be rebuilding your nav onto a problematic dependency, which means that when that problematic dependency gets refactored, your nav breaks, and you've got to refactor the nav again. So simply fire open JS, Fiddle, or Code, or whatever it is you use, and rebuild the feature there in complete isolation. Make sure it's completely self-sufficient, and then move it back into the code base. Quick example, right? We might say, look, the header, we want to move on to this new naming convention, and we want to use SVGs instead of PNGs. Those are two huge tasks in themselves, but let's just implement it on the header, and let's roll that out, and we can learn if that's successful or not. So go to JSFiddle, rebuild it, and then port it back into the project. Now obviously just copying and pasting this back into a project, there's going to be a lot of breakages, things are probably going to go wrong. So simply copying and pasting like new code into legacy isn't really going to work particularly nicely, which brings me to the next tip. I'm going to speed it, it's like I've got 15 minutes left. All initial. Who's heard of all initial? Show of hands, all initial? Oh, for those who haven't heard of it, all of your problems have just been solved. All initial is a native bit of CSS which effectively stops inheritance. It sets all properties to their initial values. Simple as that, right? It's a very progressive way of defending against legacy. The word progressive should have like a big red underline and bold, because I need to show you the browser support in a second. All initial is fantastic. Hopefully we can't really see this, but what I've got here is the HTML's got color red on it, the div element has got font point bold, so accordingly the paragraph is a bold red paragraph. As soon as we got all initial onto this paragraph, it's Times New Roman and black again. All initial just stops inheritance. It sets all properties back to their initial values. There are some oddities about how it works. Let's say we do refactor the nav. Because we've got all initial defined here, it means that the links inside the nav will go back to being Times New Roman and black. So those font properties aren't going to get inherited. We just move inherited properties onto the leaf node. It's a little oddity about how we have to write our code, but this will allow us to inherit things that we do want to inherit, move those onto the leaf node. Yeah, browser support. This screenshot's actually a little old. This screenshot needs updating. Browser support. So we've actually got a really nice amount of green on this slide, right? But we've got two very, very concerning bits of red on the left. What this means is that we can't use all initial as like a get out of jail free card. It means that this will not work for IE or Edge, and all of us at some point have to support. Like, I don't think there's anyone in here that can avoid the latest IE and latest Edge. What this means is that all initial isn't the solution to all of our problems. What it is it's a last line of defense. What this means is that if you do get any regressions, any bugs, only a small percentage of your businesses will find them, and it gets you a little more time to fix them. It means that in the green sections, you can use it and you're safe in the knowledge that most of your users will get a good experience. Regressions might trickle through to 5 to 15% of your users, hopefully, and you can fix those later. It's a last line of defense. Which brings me to my next little tip, which is defense.css. Defense.css was developed, I came up with this last year to a client who had a very specific problem to solve, very specific question to answer, and that question was, what happens when we need to rerun a refactor code and legacy completely side by side? This was a question asked of me by a company called Sky, who do broadcasting stuff in the UK. And Sky, what they're doing is they're redeveloping their brand, well, sort of subtly redesigning it, I guess. They want to roll out a brand new UI toolkit so they can put that brand across all their different properties. So they had a new toolkit developed to roll out this new brand. But the problem was, it has to be rolled out very gradually. Sky employs about 30,000 people in the UK, so we can't just turn it on overnight. Lots of different feature teams all over the country using different bits of code. We had to seed it quite gradually. So the product owners, the people in the business decided that we'll do the homepage first. We'll do responsive redesigns, and somebody said, well, let's do the homepage first. And you're like, that's not really how CSS works, but fine. We do the homepage first. If it was successful, we start rolling it out. But the problem now is that the site is using old and new toolkits. We have to run all the new code in tandem. This is a bit like having Bootstrap and Foundation on the same project. It's not as bad as that, don't worry, but it's similar. Of course, when you try to put two competing standards together, things don't really come out the way you expect. We have a lot of regressions, lots of breakages. There's this very nasty interface between old and new where things were just regressing. We had a decision to make how we fix this. So what we decided is that we'll create a third project called defense.css. And defense.css is a brand new dependency on NPM. And what defense.css was is it contained all of the fixes for all of these mismatches, all of these regressions. We just stuffed them in this file and deployed them everywhere. Now what this meant is, it seems weird to have like a third project to maintain, but the reason we did this, there are a few reasons. We ran it internal open source. What this meant is that if the homepage team had to fix loads of regressions, they could just put that on an NPM endpoint, and then the next team could take our fixes, they could just consume our fixes. anything they fixed, they could contribute back upstream, so we could then roll those fixes out everywhere. We basically crowdsource our bug fixing among the feature teams. And what it also meant is that as soon as we finished the project, we can just delete defense.css. We didn't have any legacy hanging around. This is a temporary, everyone says that's a temporary solution. This one actually is, right? This one actually is. It's a temporary solution, needs to be quick and cheap to get rid of. I was hoping to show you the kind of stuff that's in this file, but I took a look at the code of conduct, and it seems that the CSS is so offensive, I had to pixelate it. What we can see is a lot of importance, right? So this code is disgusting. Just type until it works. This is a really good way of running old and new side by side, so that we could bug fix and crowdsource the bug fixes and gradually roll them out everywhere. I am speeding through this, don't worry, these slides are online. Next tip, really little tip, when you are refactoring CSS, it's a good idea to leave a trail of what you fixed. RF classes. Any class that you rename, just put an RF in front of it. RF hyphen, it means refactored. This means that the next developer who joins the project can see that, oh, okay, this code's already been refactored, I did not touch it because it's a solved problem. It means you don't solve the same problems twice. This is quite manual though, it's very boring, it's not very sexy like this, it's RF, it doesn't really do anything, it can manually look up, it's just not very impressive. What we can do is we can use some CSS to automatically highlight problem areas. This is perfect for managers, clients, and non-technical stakeholders. If we write a selector like this, if it's a class that's got RF hyphen in it, throw a green border around it. So you can turn this on in some config somewhere, send the link to your dev site, to your project manager, and you can tell them, hey look, we're making really good progress, look how much green there is on this page. It's a very good way of non-technical stakeholders getting an idea of the current health of the project. All right, what's a green? This is going really well. Now if you're nearing the end of this represents the work we've done. If you're getting towards the end of a refactoring project, then it might be more beneficial to look at the code that hasn't been refactored, what's left over. Simply inverting that selector, by finding any class that is not a class that contains RF hyphen, stick a red border around that. And we can see here that actually there's still quite a lot left to fix on this website. This represents the work that is still to be done. Now this is a really good way of demonstrating to non-technical stakeholders the actual progress you're making, because remember, refactoring doesn't have any outward effect. It's very hard for a project manager to understand what you've actually done, which means that it's hard to build trust with them. And I completely understand why that's the case. Having something like this can actually demonstrate, hey look, oh, you could just use star, everything's got a green border and lie to them. Don't do that. But what we're using is start showing the actual progress we're making. This is the work that you've done. At the end of the project, it should be a simple find and replace, get rid of any RF hyphens from your Sass and from your views, and you're done. Really quickly, refactoring specificity. So this is a little party trick of mine. My parties are usually this boring. When you work on a legacy project, there's going to be IDs, there's going to be loads of nasty stuff left over. We can actually hack specificity around it. So when we start looking at old legacy CSS, lots of stuff left over, getting rid of IDs and nested selectors is quite difficult. It's quite hard to actually just delete those because it'll have a knock-on effect. So we can hack specificity around. Take this really simple bit of HTML. We've got an A element, a class of foo, and an ID of bar. There are three different ways of selecting this HTML. We could use the element selector, or an ID selector, a class selector, and an element selector. And because of how CSS works, this will always be blue. You cannot override that color blue very easily, unless you use an important, which we shouldn't do. We're kind of stuck with this. These legacy IDs are a specificity heavyweight. So it's important that we manage these correctly. They're very differently weighted selectors. We don't want to use important, we can hack them around. This selects the exact same HTML as before, but all of these selectors now have the exact same specificity as each other. Writing IDs as attribute selectors lowers their specificity down to a class. It still selects an ID, but with the specificity of one class. The middle one, we can see we've just introduced a class with a specificity and an element. And the bottom one, we can introduce class worth specificity by using the root pseudo selector. Now, this isn't a very digestible slide, so I'll pull it out to a more digestible slide, which just lists these hacks. Writing IDs as attribute selectors brings their specificity down to the same as a class. That means you can get rid of ID specificity without having to refactor any of your views. If you chain a class with itself, its specificity increases by that amount. So .foo just selects one foo class in your HTML with double the specificity. 3 times it will treble the specificity. These aren't perfect, these aren't ideal, but these are a better way of hacking specificity than using important. And finally, the root element, or the root pseudo-selector, always exists, and it always carries one class worth of specificity. So if you need to artificially insert a class worth of specificity into the selector, just use the root element. And also the root element can be chained like a class can. Now these are hacks, don't go and do these aren't great. Use these when your other option is to use important. On the ladder of badness, these are only one rung down from important. These absolutely are hacks. Ideally, refactor if you don't need them. Realistically, just use them as hacks, but never use important. There is a place for important in modern front-end development. This isn't it. Don't use important in Angular, right? Use one of these hacks instead. Approaching the last thing I want to talk about, I apologize, I have had to speed up massively towards the end, but who's heard of shame.css? Yeah, a few of us. It's in really bad taste to quote yourself in a slide, but I've done it anyway. This actually comes from the article I wrote about shame.css. Me and a friend were joking around about, like, where should you put your hacky, nasty bits of code? And we said, well, the good thing about CSS is it can technically live anywhere. You can't just pull like a JavaScript outside of its function, but you can move CSS pretty much anywhere. So move all the bad stuff into its own dedicated file. So it's easy to find your hacks later. So shame.css is basically a dumping ground for all the nasty bits of code that you wrote. You didn't want to write them, you kind of had to, you kind of release to get out on time. Hacks are inevitable. There's no way of avoiding the fact that we'll need to hack things around. Isolate and signpost them, make sure they're detectable, easily findable. What the shame.css becomes is it becomes your list of tech debt. All of your CSS tech debt now lives in one file. It's really easy to find. An example entry into a shame.css, using the class hack to increase the specificity button, but the most important thing on this slide isn't the hack, it's the comment. Always explain anything that's unconventional. Also, you can get away with a lot of bad work if you just write sorry. You can get, the problem with undocumented code is it still has to be read and understood and reverse engineered before the next developer knows if they need it or not. By writing a comment explaining why it exists, the next developer knows that, oh look, this doesn't affect any of my work, I can safely ignore this. I also explain to that developer how we're going to fix it when we have enough time. So shame.css, all your bad code should live in there, all your nasty stuff should live in there. It becomes a self-writing to-do list. Instead of leaving to-dos all through your code base, start putting them in this thing, in this file, and everything is there. It keeps your good code nice and clean. I don't have time to go into this, but the broken windows theory, give that a read. It's a really good analogy for declining quality. See which parts of the code base are particularly problematic. If you've got a load of features that always end up in shame.css, that's a good indicator that feature was badly designed or badly implemented. Therefore, that is probably the thing you should refactor next. Tell your product owner that, hey, look, the carousel has got at least 75% of the lines in this file. That needs redesigning. Also, it's easier to git blame one file than it is an entire project. This helps you understand not who's a bad or a good developer, this helps you understand who is struggling with which bits. If one developer is constantly contributing hacks for one specific feature, maybe it wasn't explained to them very well. This isn't a way of shaming developers, save the guy who called it shame.css. This isn't a way of shading developers, it's a good way of understanding who understands what or what skills might be missing or what knowledge might be missing from individuals in your team. The last thing, right, that I want to leave you with, I had a really interesting thing happen to me about 4 years ago. I was doing a workshop in London, like a public workshop, where members of the public turn, they buy a ticket and they turn, and every workshop I go around and I get people to introduce themselves, what they work on, what kind of things they're interested in and what their background is. And one guy said, oh yeah, I'm actually like a civil engineer. I just had like a bit of a midlife thing where I wanted to change my career, and I went from civil engineering to web development. And I was like, oh, that's really cool, like, that's very brave of you, and how are you finding web development? And he said something I'll never forget. He said, well, in my day job, I used to be building roads and bridges, and if I get a bridge wrong, like 200 people die and I go to prison, right? I can't refactor a bridge. I love being a web developer because I can always improve my work, even after it's finished. Because code is cheap. He was like, well, I can't believe that I get the ability to change things that I learn. With a bridge, you have to get it right first time. No option, no other option, get it right first time. With code, you can learn that, oh, in 6 months' time, actually that wasn't the correct thing to do. I'm going to go back and change it. nobody dies, unless you're building like nuclear reactor software maybe. But he loved being a web developer. He said, yeah, I'm a civil engineer by trade. We don't get to refactor our architecture. I love being a web developer because I get to refactor everything. The more I learn about the system, the more I get to change it and tweak it and modify it. This made me realize that in a very kind of philosophical way, refactoring is actually a second chance that a lot of industries don't get. Now, I still hate refactoring. I still don't like refactoring. But what I am aware of now is the fact that refactoring is actually something of a privilege. Refactoring is something that we get to do. Sometimes we have to do it, but sometimes we get to do it. And that's actually quite amazing. We get these second chances. So yeah, to recap. Prevention is cheaper than the cure. Keep on top of your tech debt, pay it off as soon as you can, lie to your project managers and just tell them you're working on other things while you're tidying things up. This project manager sat right there, I shouldn't have said that. Tech debt is fine, just make sure you keep up your repayments. Refactor, once you can see tangible benefit, avoid refactoring prematurely. Avoid long refactoring tunnels, pick small, sensible bits of things to refactor. And isolate and signpost and highlight both your hacked and your refactored work. The very, 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 very last thing I want to leave you with. A guy called Robert Baden-Powell, Sir Robert Baden-Powell, a founder of the Boy Scouts movement. He's got a famous saying, which is always, he told his Boy Scouts this, he's like, always leave the campground cleaner than you found it. And in a weird way, I think we've got a responsibility to developers, a responsibility to our colleagues, the next developer. We've got a similar responsibility to try and leave a project cleaner than we found it. Thank you for your time.